We're going to be looking at example 2 in your section 4.4 notes. So in this example, we want to draw the graph of our function f given the properties in the box. So we'll start with the first derivative. So you'll notice in the first two lines, it says that the first derivative is less than 0 or negative. So I'm going to put negative signs on my sign interval, which I already have drawn. So it's negative from negative infinity up to negative 1, and then it's also negative from negative 1 to 2, okay? Then I know that my first derivative is greater than 0 or positive for the rest of the intervals, from 2 to 8, 8 to 10, and 10 on out to infinity. So what this means for us is that everywhere we've marked negative, that tells us the function f is decreasing. So it's decreasing from negative infinity to 2. And then it's increasing from 2 on out to infinity because of all the positive signs. We also know, because it's decreasing to 2 and then increasing afterwards, that 2 is a local min for our function. Okay, so that should be a low spot, all right? So we can actually go ahead and do that part. Mark here for 2. Just go ahead and draw a low spot, getting ready to go. And then you can kind of say, I want to come decreasing on this side and increasing over here, even though we can't fill out any more than that until the second derivative information. Okay. All right, for our second derivative information, we have this and this for less than 0. So those are going to be our two negative intervals. So less than negative 1, and then from 8 to 10. So those are going to be the two spots where our function f is concave down. So from negative infinity to negative 1, and then 8 to 10. Okay, the rest of the intervals are where the function is going to end up being concave up. So we'll go ahead and fill in plus signs because of the greater than 0. So we know that f is concave up from negative 1. Okay, and this goes all the way over to 8. And then it's also concave up from 10 out to infinity. Okay. All right, so this also tells us because we have changes in concavity at negative 1, from concave down to concave up, and 8, okay, which goes from concave up to concave down, and then also at 10, that we have these three values are going to be inflection points. So negative 1, 8, and 10, go ahead and abbreviate those as IP, inflection points. All right, so I'm gonna go ahead and draw negative 1 there, okay. I'm gonna put an 8 right over here, and I'll extend this just a little bit, give me a little more space, and there's my 10, okay. All right, so I need to be dropping this entire side of x equals 2, but I gotta be careful how I do it, okay? So I know that I wanna be concave down from negative infinity up into negative 1. Okay, so I'm gonna go ahead and make a star there. There's my inflection point, and I just wanna make sure that I'm concave down. So I wanna bend down to right there. Okay, now we said from negative 1 all the way to 8, we're gonna be concave up. So we can go ahead and start making that bend up. Okay, so it's definitely bending up, okay, as it's decreasing. And then we wanna go ahead and keep bending up until we get to 8. So I'll make another star for an inflection point there. So that whole section is concave up. All right, now we said from 8 to 10, we're gonna be concave down. So I'm gonna make a star for that, but I wanna make sure that I bend down. So there we go, bending down, okay? Still increasing though, all right? And then from 10 on out to infinity, I wanna be concave up. So I still wanna be increasing, but I just wanna bend upwards as I do it, okay? And that gives us a sketch of our function f and completes example 2.